Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. Determine the minimum angle that capital L can make with the z-axis when the angular momentum quantum number is L equal to 4 and part B L equal to 2. Okay, in part A L is equal to 4 and in part B L is equal to 3. L is equal to 2. Okay. Determine the minimum angle that L can make with the z-axis when the angular momentum quantum number is in part A L equal to 4 and in part B L equal to 2. Okay. Now we come to its solution. But before coming to its solution in a formal manner, we first go through a number of slides. These slides will provide a foundation regarding the solution of this problem. Okay. First snapshot is electron angular momentum capital L is equal to under root into small l plus 1 into h cut, where h cut is outside the under root and h cut means Planck's constant divided by 2 pi. Okay, h cut or h reduced. Okay, with the orbital quantum number small l restricted to the values small l is equal to 0, 1, 2, 3, 4, 5, 6 and so on up to small n minus 1. Okay, that is to say small l can never be equal to n. It is at the most less than 1 less than n. Okay. Next snapshot is about space quantization. Capital L into small z into capital Z written as a subscript of capital L. Okay, LZ equal to MLH cut. Okay, where small l is written as a subscript of m. In some books this small l written as a subscript is not written and simply m denotes ml. Okay, next h cut, where h cut or h reduced or h bar is Planck's constant divided by 2 pi. Okay, here ml is equal to 0, plus minus 1, plus minus 2 and so on up to plus minus small l. Next snapshot is about spatial quantization. Cos theta is equal to Lz over capital L mod modulus value. Okay, this becomes equal to ml, where small l is written as a subscript of small m divided by under root l into l plus 1. Okay. Next snapshot is a combination of some different formulas. Okay, first is orbital angular momentum capital L bar mod or modulus value equal to under root L into L plus 1 into h cut or h bar or h reduced, that is Planck's constant divided by 2 pi, where small l is equal to 0, 1, 2 and so on. Okay. Next snapshot is about orbital magnetic quantum number. This is Lz is equal to MLH cut or h bar or h reduced, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Okay. Here ml is equal to 0, plus minus 1, plus minus 2 and so on up to plus minus small l. Next spatial quantization. Cos theta is equal to Lz over L mod is alternatively becoming equal to ML over under root L into L plus 1. Okay, next dear students, next snapshot was also included in previous problem. However, once again we take a notice of this snapshot. Okay, allowed values of quantum numbers for one electron wave function. Okay, small n is equal or greater than 1, where small n is the principal quantum number, then small l, that is orbital quantum number, is either equal or less than n minus 1, and on the other hand either equal or greater than 0. Okay, next, small m small l, where small l is written as a subscript of m. Okay, that is orbital magnetic quantum number. Orbital magnetic quantum number. Small l was simply orbital quantum number. Okay, this small m is orbital magnetic quantum number, and its modulus value, mod or modulus value, absolute value, is equal or less than small l. Next is spin magnetic quantum number. Okay, this ms is either equal to plus half or minus half. Okay, now we move forward and come towards part A. Part A, L is equal to small l equal to 4. This implies that when small l is equal to 4, then capital L, or modulus value of L vector, becomes equal to 4 into 4 plus 1 into h cut. So it becomes 4 into 5 h cut. H cut is outside the under root. This becomes equal to 20 h cut. Okay, now next, Lz is equal to ml h cut or h bar or h reduced, where h cut or h bar or h reduced is equal to Planck's constant divided by 2 pi. This is equal to, this becomes equal to 4 h cut. Now cos theta minimum, that is where min or minimum is written as a subscript of theta, becomes equal to Lz over capital L mod or modulus value, absolute value. Okay, this becomes equal to small m small l, where small l is written as a subscript of m divided by under root small l into small l plus 1. This becomes equal to 4 h cut over 20 h cut. This alternatively becomes equal to 2 over 5 under root. This alternatively becomes equal to 0.89. This implies that when cos theta is equal to this, then theta will be equal to cos inverse that value. Okay, here min is also written as a subscript of theta. Okay, that is minimum angle, theta min. Theta minimum becomes equal to cos inverse 0.89. When we take the value of cos inverse 0.89, then it becomes either equal to 0.47 radian or alternatively equal to 27.12 degree. 27.12 degree. Dear students, I have taken the value of this cos inverse 0.89 from online inverse cos calculator. Okay, there may be other ways to find out these two values. Okay, that is either 0.47 radian or 27.12 degree. Okay, this was part A. Similar is the case with part B. In part B, we have small l equal to 2. So when small l is equal to 2, then this implies that capital L, or modulus or absolute value of capital L vector, becomes equal to 2 into 2 plus 1 into h cut, and this becomes equal to 2 into 3 into h cut, where h cut or h reduced or h bar, which is equal to Planck's constant h divided by 2 pi, is outside the under root of value. Okay, this becomes equal to 6 under root into h cut, and Lz is equal to ml h cut, and this becomes equal to 2 h cut. Now cos theta minimum is equal to Lz over L mod. This becomes equal to ml over under root L into L plus 1. This becomes equal to 2 h cut over 6 under root h cut. Dear students, here h cut will be cancelled with h cut, and we will be left with 2 under root over 3 under root. Okay, because 2 can be written as a 2 under root into 2 under root, and 6 under root can be written as 2 under root into 3 under root. So 2 under root will be cancelled with 2 under root, and we will be left with 2 under root over 3 under root. In other words, 2 by 3 whole under root. This is equal to 0.82. So when cos theta is equal to 0.82, then theta minimum will become equal to cos inverse 0.82, and from online inverse cosine calculator, this value becomes equal to 0.61 radian, or alternatively equal to 34.92 degree, which can also be written in this way: 34.92, not written as a superscript of 92, not or 0. Okay, we can also write it as DEG, and we can also write it as a not as a superscript. Okay, now this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.